All right. Hey, everyone. Okay, so hopefully you guys all see this document under tomorrow's morning review. We can get a head start on the review if you'd like. So it's there for you if you want to access it and put it on OneNote, or if you want to follow along from there. Okay, so we have position function given. Particle moves along the x-axis, so there's only a left and right movement involved for this object. We have a position function of t squared e to the negative t, find velocity and acceleration. So what do we have to involve here to find the derivative? Product rule. We got to recognize that t squared is one expression, e to the negative t is a different functions. They're being multiplied together. Okay, so, but another option is you can bring that e to the t down to the denominator and go through quotient rule. But same thing, we're going to get the same result. Okay, f prime g plus f g prime. Combine like terms. Any questions with f prime g and f g prime? Notice that g prime requires a times -1, e to the u times u prime. Right? Combine my terms here. Recognize that I have a GCF I can take out, t e to the negative t. So this will come in handy when we are ready to sign line, but we're going to go ahead and move into and find our acceleration function. Okay, any questions there? Now, if I want to find the acceleration function, what do you think we need to do here? Let's start here. I think this is an easier place to do here. What do you see? What's needed? What do you guys think? Right. We also need product rule, but what makes this a little bit longer? Twice, yep. 2t and e to the negative t, that's, we got to go through product rule there. And then t squared e to the negative t, we got to do product rule there as well. Right. Yeah, it's a little bit more extensive because of that. Combine some like terms there. Clean up. And I make my way all the way down to t squared minus 4t plus 2 with e to the negative t as my common factor. Okay, any questions with A or B, finding velocity or acceleration? Okay, so now determine interval moving left. So what information do we need to determine interval moving left? We want to create a what?
Velocity sign line.
Velocity sign line, right? So what we need is a critical point to place onto the velocity sign line. So we set velocity equal to 0, right? So this is a good place to look for critical points because we have t, e to the negative t, and 2 minus t. These are all nicely factored. We can think of this 3 separate locations to find our critical point. So if we take our velocity function set equal to 0, t is equal to 0, e to the negative t is equal to 0, 2 minus t is equal to 0. If we try to take the natural log of both sides, nothing is going to come out of that. We have 0 and 2, and so those are our critical points. Okay. We want to test the velocity on either side of our critical points. So I can test -1, test 1, test 3. And I'm testing all this against my velocity function. Right? So I'm looking for particle moving left. So moving left is negative velocity. So I want the interval from -infinity to 0, and then the interval from 2 to infinity. All right, any questions there? The reason why 1 is positive is because e to the -1 is still positive. E to -1 is same thing as 1 over e. So it's 1 over 2.7, which is just like 1/2. Yeah. Basically, e raised to any power just means that we're taking the reciprocal of that number, and it's still going to remain positive. Okay, good so far. Okay, part C is the particle velocity increasing or decreasing at k equals 3. Particle velocity. So we look at what?
Acceleration.
Yeah, just acceleration. Yeah. Okay, so we plug 3 into acceleration. We're going to end up getting a negative number. So negative acceleration means velocity is decreasing. All right, see you guys. Okay, what about D here? Is the particle speed increasing or decreasing? We look at both velocity and acceleration, right? Okay. So we plug 3 into the velocity, we get a negative number. Acceleration into the velocity, 3 into the acceleration, we also get negative. So 2 negatives, they're both the same sign. Speed is increasing. See you, Claire. Right, any questions with number 1? All right, let's look at number 2. Do you notice anything strange about this problem here?
There's a variable in the exponent.
Yeah. Well, the variable in the exponent itself doesn't make it odd, right? There's something else here. There's a variable expression in the base as well, right? So you have a variable raised to a variable, and we just don't have a rule that is explicitly for that. So we have to rearrange the problem, right? So what do we have to involve here? What's this called?
Log differentiation.
Yeah, log differentiation, right? Take the natural log of both sides, and then we can see where that leads us, right? Okay, take the natural log of both sides. Okay, what would you do next?
Bring the 2x over.
2 to the x, let's bring that down. Okay, so left side is implicit. Right side, we have to use what?
Product rule.
Product rule. F prime g plus fg prime. This is base a to the u. This is natural log of u. So you have to use the rules right. This is rule number 4. And natural log parentheses, that's rule number 1. Left side is 1 over y dy dx. And the right side, we're going to start our process, product rule, right? Okay. So a to the u, 2 to the x becomes natural log of 2 times 2 to the x times x's derivative, which is 1. We keep the g function, which is natural log 3 minus 5x, plus the original f function, and then we move on to g prime. So g prime is u prime over u because we have a natural log expression, so negative 5 over 3 minus 5x. Any questions there?
Could I see the little formula sheet again?
Yeah.
Okay, thank you.
Mhm. Okay, what can we do next? I'm not going to worry about cleaning this up, but I do need to do a few more things. What can we do?
Move the y to the other side
Mhm.
line using
And then-
receipt.
And then once that y is moved over, one more thing.
Substitute it.
Yeah, substitute that y back in terms of x. So once we get done with log differentiation, the only thing that should be showing are x's on the right side. Okay, number 3. Okay, so I put in the chat box the link to this worksheet in case people joining late didn't know where this was coming from. All right, number 3. Okay, we have a log base 7 problem. We're asked to find the derivative. What would you do first? Expand it, right? You got a numerator term, you got 2 denominator terms. The numerator term is going to be part of a positive log. The denominator will be part of a negative log. Okay. Spend a minute, try that. And that 3 is going to tag along to every term. There's going to be a 3 in front of every log term that we expand. Okay, what can we do next?
Can we move some of the exponents down in front of the 3?
Yeah, you can bring the exponents down, yeah. Bring that 1/2 down. You can bring this 2x down if you want. I'm going to leave that there. If you bring it down, well, you'll get the same. Your answer will look a little different, but it's the same thing. So it's up to you. But I'm just going to bring that 3 down, or the 1/2 down. So now we can approach this from a derivative standpoint. The only rule that we need is this one. And the 3 and the 1/2, they're just going to tag along in front of the as coefficients in front of the derivatives.
Mr. Yang,
Yeah.
why did the X go away?
In the first term
Oh,
of the
right.
previous step.
I think I, sorry, I messed up here. I think I lost track of that and I made it into a 0. So let me change that. So second term here, I decided that I want to use the rule. I'll leave it in this form. So jumping to the rule for e to the u. E to the u becomes e to the u times u prime. So I guess we do have that rule going on here as well. Okay, any questions about any of these steps here? Everybody okay?
Will you talk through 3 log 7 e
Yeah.
to 2x?
So I'm starting off with this rule here. The 3 stays. log base 7, that's my a value, and this is my u value, right? A is 7, u is e to the 2x. So we move into a rule, 1 over ln of a, so 1 over ln of 7, with a 3 coefficient in front, so we're good there, right? So now we're ready for the u prime over u. So my u value is e to the 2x, so I need to find u prime, I need to find the derivative of e to the 2x and put it in this location here. So the derivative for e to the 2x is going to be e to the 2x times 2, so that's going to occupy the space in the numerator. Divided by the u value. The e to the 2x cancels out nicely. I'm just merging some of these terms together. 3 and 2, I get 6. 3 times 2 is 6.
Yes, sir. Thank you.
Okay, anything else with 3? Right, number 4. Thank you. Okay, what process do we have to go through here? What do you notice?
Would it be implicit?
Yep, good. Implicit differentiation. Bunch of y's, right? What else? I see it.
Isn't there a little natural log like quotient?
Yep, good. We have expansion property. What else?
Product rule?
Yeah, there's a derivative product rule, right? That 3x squared y, you got to be aware of that. Good. So expansion comes first, right? We want to take care of all the pre-derivative things that we can do before we jump into our derivative step. So once you expand, you're using quotient property, you may need to do a little bit of power property as well. So everything up to this point, I'm just cleaning up that left side. I'm not doing anything with the right side yet. Okay, we're ready for our derivative rule now. Natural log is u prime over u. We have power rule. We have u prime over u. We have product rule. We have implicit. So how many y's do you see here? 3, right? So what does that indicate to you? The next line should have what?
3
dy.
3 dy dx's. Okay. That's a quick way to kind of double check that you have the correct number of those derivative variable of dy dx popping up. Okay, product rule here, right? F prime g plus f g prime. When we get to g prime, y becomes dy dx. And this is my suggestion here. When you have y by itself, the derivative is dy dx, but put a 1 here. That way, when you factor dy dx out later, you don't forget that there's a number there. So I think having that 1 is kind of safeguards us from forgetting about that there's a term sitting there. 5x becomes 5. 3 goes away to 0. So that completes our derivative process. The rest is just trying to get that dy dx by itself, right? Okay, so we're just adding and subtracting a bunch of terms, kind of moving things around. Okay, factor dy dx out, divide the rest of it over. Any questions with 4? All right, number 5. Find tangent line equation for our function at 1, 0. So we need to find our slope. Because we already have the order pair, we just need to find slope. So how do we find slope? First, find what?
The derivative.
Derivative.
Yeah. And to find the derivative, we have to use what method here?
Product rule.
Product rule. Yeah, try that. Okay. F prime g plus f g prime. You don't have to clean up because really we just wanted to get the slope, but I figured if I clean up a little bit, it'll make it easier for me to identify my slope value, but it's up to you.
That's pretty right.
Question?
Yes. So for the F and G prime, the how did the X go away?
Oh,
for
wait,
the-
yeah. I lost the X, didn't I? I was rushing creating this worksheet here. Okay, so I have my derivative. Replace my X values with 1. Natural log of 1 is 0. 0 over E is just 0. 0 plus 1 over E is 1 over E. So there's my slope. Got my order pair, my slope. Okay, any questions here? So in class, I rushed through these problems. Got an implicit, log differentiation here. Got a derivative inverse at a point. Log expansion followed by derivatives. And then implicit expansion product rule. Are there any one of these that you want me to slow down and go through with you step by step?
Inverse.
Inverse, okay. Let's do the inverse one. Okay. Derivative of inverse at a point. This is not on your sheet here. Just copy this down. Okay, here are the steps. Okay, what's our first step? What does that 2 represent?
Y.
It's the y value of the function, right? It's the x value of the inverse, but it's the y value of the function, right? We're dealing with this inverse relationship here. Yeah, so y is 2. So that's going to go in to our y location. All right, what's next? I mean, we can do guess and check, but I like to get a 0 to show up. Makes it easier, I feel, to go through guess and check when I can compare my number was 0. Okay, next.
X would be 1.
Yeah, let's just choose values, right? Test some numbers around. Test some numbers, see what works. So we'll start with 0. Does 0 work? Yeah, so we'll try if 0 doesn't work, we'll try 1. If 1 doesn't work, then -1, then 2 and -2. Okay, but here I think 1 works, right? Like Thomas said. Okay, so we'll set that off to the side because we're going to need that information. We know our order pair is 1, 2. Okay, what's next? F prime. Okay, what's a derivative? From the derivative, we can find the slope, right? You got the 1, that's why this 1 is going to help us out, right? Find the slope using 1. Slope equals so if the slope of my f graph is 5, then the slope of my inverse is going to be what?
1/5?
1/5, reciprocal. So this is what might be happening here. You have order pair 1, 2 for the function. And then you have on the inverse side of things 2, 1. And this may not be the shape of the graph, but we found the slope of the f graph being 5. And then the slope of the inverse at its point is going to be 1/5. Okay, any other questions? Salsabile, you have anything? No questions? Thomas, you okay? Daniel, questions? Okay. So tomorrow morning, I just plan to kind of go over these problems again. Some of you may not have time tomorrow, so afternoon session kind of gives you a head start if you want to try these problems from scratch. I think that will be good as you practice tonight. I would encourage you to, I have this under today's link, point of inflection involving natural log. We did this last Friday, but I think it's good to be comfortable with this type of process. Okay, any questions?
Mr. Yang, okay, this is so random, but I saw this on one of the worksheets and I'm really confused. It's just the simple equation kind of deal. Y equals e squared, then the derivative of y is 0.
Yeah, that's right. So y equals e squared. E is a number. So imagine if it was just like 2.71 squared. So y is like 7 or 8, something like that. So it's a constant basically. These are all constants. What's the derivative of a constant?
0.
0. There we go. Yeah. I know that e looks like a variable, but it's not a variable, so we got to remember that's a number. A number squared is still a number. Constant goes to 0.
All right, sounds good. Thank you.
Yeah, practice these problems. Practice some more of first derivative, relative max, relative min, POI. Right. I think you guys have seen enough variations for you to practice with. Okay. All right. Have a great day.
Thank you.
Thank you.
See you guys tomorrow.
Thank you, Mr.
Bye.
Do you have like something on your website with like all the equations like this? Or like in your
Yeah, hold on a second. End this session here.